talked about. How many of you have no idea what's going on? Good overlap. I approve. I approve. All right. So we'll just start going through some of this stuff. I know many of you are not only new to HOTRFC, you might be new to the IETF as well. And as with everything you will see this week, we start with a note well. The note well is sort of it's the policy for how you contribute, what happens to those contributions, what it all means, and all of the kind of reading material that you should get into to understand what the intellectual property components are, what your copyright rules are, what your behavior rules are. In addition, we get into a little more detail, and again, you're going to see this over and over and over this week, that these meetings are, we're here because we want to collaborate. We want to learn new things. We want to have healthy debates. You don't have to agree with everything you hear, but you do have to be polite about it when you say you don't like it. And we want to make sure that there's a lot of different cultures represented, a lot of different ways people are used to engaging, and we respect all of them. If you don't like what you're hearing or you feel something has gone horribly, horribly wrong, there are ways to get that resolved, and you are encouraged to just find someone with a dot and they will help you. Okay, again, I'm putting these slides up so that you can start to get familiar with them. And by the end of the week, they will be burned into the back of your brain, never to be lost again. In this case, the meeting is being recorded, but there will be no questions to anything that you see in terms of the presentations. If you have questions, remember what the speaker looks like and go find them later. There are a variety of resources available for IETF 121. We have an agenda. We have information on how to run MeetEcho. And again, if you have any kind of technical issues, there are ways to get there. Of course, you actually have to sort of almost get to the technology to report your technology issues, unless you go up to the second floor and you find, say, the NOC or some other groups that can actually help you out. That was sort of all the preliminary boring stuff. Now let's talk about this session right here, right now. HOTRFC is an incubation point where people can come up with brand new ideas and toss them out there to see, what do you think? Let's talk about it some more. The people who are presenting get 4 minutes. 4, not 5, not 6, not 12, 4 minutes. If they have 2 slides, that's cool. They get 4 minutes to talk about it. How much time do they get if they have 12 slides? 4 minutes, that's right, right? And at the end of 4 minutes, there will be a round of applause requested. It looks like that. Let's practice. Well done, I approve. All right, again, you don't ask your questions here, you ask your questions out there. The slides will be available in the data tracker, so if you do want to follow up on something, that's another way to do it. You are strongly encouraged to do so. Who's actually presenting today? I know we have Phil, we have Stuart, okay. For you, there will be a little clock right there on that monitor that's going to count down, and it's even going to change color. Pay attention to your clock. And then there will be a wild round of applause. Well done, well done. And with that, we are going to go straight over to Philip to talk about palimpsest.
I would like, yes. Okay, so this is not quite very new work in, how do I do that? This is based on work done by my colleagues at MIT, John Mallory and Roger Hurwitz, who did a really great web interactive conference for Vice President Al Gore as part of the National Performance Review. Only problem was all those innovative features required a Lisp machine to run them on. MIT iLab, of course. So over the past 2 weeks, I've rewritten it all in C#, and now you can run it on any machine you like. And what you can do here is you can upload an IETF draft and comment on it. So first thing you do, create an account, and you see note well. Click. Okay, create a project, kind of like group together a bunch of, maybe more than one draft with one comment thing. And then once you've created a project, you can upload documents into that project. And at the moment, only XML format is supported, but the underlying tools actually support editing your drafts in Word or Markdown if you don't like the XML. And so here the document's been uploaded, and you can see on the right-hand side, all the sections have been noted. And then we're going to click on one of them, abstract paragraph 2, and we're going to enter a comment. So now we've entered a comment, and then when we come back, and you notice that the comment has a semantic tied to it. So the semantics could be raise a question, provide an answer to somebody else's question, agree with some piece, provide some textual objection, say, you've got a typo. And the idea is to guide people into providing a little bit of a hint to how that comment's going to be disposed, so that then we can have tools that manage them in interesting ways. So now when we go back to the draft, to see when you're looking at the draft, you're also seeing the annotations in line with the part of the document that's being commented on. And you can also press a button and it will collapse out all the paragraphs that don't have comments on. And then the idea here is that each of these comments has a trace associated with it. So somebody asked a question, well, somebody can answer it. And if the person asking the question agrees, well, that's closed and, it just gets archived. If it's a textual point, hey, you've missed this full stop. Again, agree, closed. And you might raise, and the idea here is that raising issues should be the abnormal processing rather than the go-to, which is what happens when we're editing it on GitHub. Obviously, there are ways of raising issues, but then contra-wise, when you close an issue, you should be able to tie it back to the pieces of the draft that change as a result of closing that issue. Okay, so why not just use GitHub? Well, GitHub's not designed to do this. This is designed for this purpose. So instead of telling people, hey, send a PR, and then explain how to submit a PR on their iPad, this will actually do the thing that you're trying to tell them to do. Okay, and yes, it does have end-to-end security if you want it, but not for IETF use. Okay, thank you.
Well timed, sir. Well done, Philip. Perfect timing. All right, our next one is Ming, large language models for networking. Don't worry, we don't turn on the clock until you start talking. Here you go.
Oh, so you can do the first part in mine.
No, you can do it interpretive dance, because I would see that. Go ahead.
Okay, ready?
Okay, hello everyone. My name is Ming and I'm from Beijing Zhongguancun Laboratory. Today I'm glad to share our paper, our slides about using large language model for networking. First, let's summarize the main challenges of the network modeling and decision tasks. That includes the complex network environments and the diverse user requirements and the rapid network iteration cycles. The traditional methods typically use hypothesis-based or statistic-based methods to model the network behavior. As the machine learning models has shown its powerful function fitting capability, some researchers also use it with domain-specific dataset to train the machine learning models to accurately model to predict the network behavior. Recently, the large language model also shown its conceptual understanding, logical reasoning, and tool utilization capabilities. and some researchers turn to use a large language model with extensive dataset and large-scale parameters to conduct some network research. A demonstration is that on HotNet 2023, there are 2 out of 9 sessions are dedicated to this topic. This shows that this topic here is really hot, and many researchers follow this topic. After surveying the recent studies about applying large language model in networking, we abstract a workflow for this task. First, we need to give task definition and data representation. Then we need to use prompt engineering to construct the prompt for the large language model. And with advanced tool integration, and we can get this final action. It also should be validated with testbed or simulator. Finally, I will introduce challenges and give some future research direction. First, the large language model needs to understand the data with multimodality, such as the raw traffic or the device log. Secondly, we need to develop prompts for reasoning complex network tasks. For example, we can use chain of thought or tree of thought to divide the complex network tasks into easier subtasks. Thirdly, we also need to develop network-specific large language models, as just a few of current large language model are specific for the network domain. We also can to compress the model size of large language models to enhance its efficiency and performance. As we all know that the large language model's output is untrusted, so we also need to design some post-verification algorithms to ensure its reliability and safety. Finally, I'd like to introduce our side meeting about a large language model in networking. It will be held on November 5th. We also invited five speakers from including researchers and senior engineer. They will talk about their recent practice on using AI or large language model in the networking tasks. So welcome you to attend the side meeting. Thank you.
Okay, now breathe. All right, next up we have Roland Bless talking about Kira Scalable Zero Touch Routing. Here you go, sir.
No, it's just a single slide.
Single
Thank you.
slide.
Yeah, single
Wow.
slide. Okay. Yeah, so my name is Roland. I just want to bring Kira to your attention, which is a scalable zero-touch routing architecture. What means scalable? It scales up to 100,000 of nodes in a single domain, so it's flat, doesn't need any structure. It is a zero-touch approach, so it doesn't need any manual configuration and adapts to new topologies and stuff. So the goal, what can you do with it, is to provide a very resilient autonomous control plane connectivity, which is of interest or should be of interest of many of the network operators that operate a complex network. So you shouldn't lose control over your control plane. And that's the goal, to provide resilient connectivity for that. So the idea is that every network device runs Kira, and so you can get back to any network device and do not lose control over your device. And therefore, we need an IETF standard in order to do that, because every device needs to speak that protocol. There's an internet draft that you can read and should read, and please comment. We also have running code, which provides zero-touch IPv6 connectivity. Needs more work, but yeah, there's certain beginning for that activity. So we are looking for collaborations toward BOF, or whether you're interested in the work, also interest maybe to implement Kira, then come to the site meeting on Wednesday, 7 p.m. in the Wicklow meeting room 4. And there will be given a short introduction and overview of Kira, so you don't need to read the draft beforehand. You can, but you don't need to. And there will be questions and answers and also talk about future collaboration. Thank you.
2 minutes? 2 minutes? Wow, that was hot. That was super hot. Okay, Manu Fontaine, where are you? Come on up. Extrinsic, intrinsic, decentralized, and STEM identifiers.
Hi, my name is Manny Fontaine. I've been coming to the meetings for about a year now, sharing work that we're doing on the Universal Name System and the Universal Certificate Authority, and this is progressing very, very well. And we've been trying to explain what we're doing in different ways. It looks like it's coming down to the nature of the identifiers that we manage in the infrastructure. So I wanted to bring this to your attention. Oh, there we go. So we essentially propose a new type of identifier, an identifier that sits at the entity level, a complex entity level. We define an entity as anything that needs to have its own individuality, authenticity, history, and relationships. And for that to be maintained, it basically needs integrity, provenance, confidentiality for all the data objects that may be scattered across a distributed system like the internet. And so why bring it to the IETF? Because pretty much everything is a complex digital entity. People, organizations, we see use cases in chips, IoT devices, code snippets, executables, workload identities. Virtually any item that exists in any supply chain is a complex digital entity. So comparing it to the types of identifiers that exist out there that have been somewhat defined, we are all familiar with extrinsic identifiers. The problem with them, of course, is that they require trusted roles, people who maintain associations between the identifiers and the objects themselves. Of course, now it requires trust, so which undermines integrity and confidentiality. We're all familiar with intrinsic identifiers like hashes and Merkle trees and all that good things that are great for, Git and other things, but primarily good for things where the objects don't change, or we don't want the objects to change, and we want to make sure that the objects have not changed. So that's great. But if the objects need to change, well, then lots of people have been proposing decentralized identifiers, DIDs, where we basically now are using the math properties of intrinsic identifiers, but we use public-private key pairs to just somehow, fuse together identifiers and claims and other things like that. It still requires trusted roles because there's no verifiability of the key management behind those, verifiable credentials and things like that. So what we propose is STEM identifiers, and basically a STEM identifier is an identifier that only exists and lives within trusted execution environments. So we're talking about confidential computing technology here. And essentially those STEM identifiers give us the mathematical integrity and verifiability, and also enable what we call STEM encryption, just a cute term to try to combine a few things here. We define the STEM identifiers as basically random 256-bit identifiers, but with generated full entropy. So what's kind of interesting is that they actually are the combination of an identifier and a key. So it's an identifier with cryptographic capabilities or properties built in. It looks like this, but you're never going to see one because it's 43 characters, but they only exist within TEEs. And STEM encryption is the idea of encrypting data with keys that are derived from the identifier itself. Because the identifiers has full entropy, is random, you can use it in a key derivation function. I have 20 seconds left. So I'll talk to you then more if you're interested at the side meeting that we have tomorrow at 1:30. Where I can give you a sense of how we've stumbled onto that concept and how we're building it into the UNS and the UCA. Thank you.
Thank you. And thank everybody. You're doing a really good job with The Crowd Goes Wild. I appreciate this. Right, next up, round trips per minute with Stuart Cheshire. There you go.
Thank you. 4 slides, 4 minutes. In the last 40 years, our industry has made enormous progress in terms of throughput. We've gone from dial-up modems to gigabit service to the home. But the realistic round trip time has really not changed at all since the days of dial-up modems. In fact, in some cases, it's even got worse. Why is this? Engineers work on what they get rewarded to work on. And we have many, many tools for measuring throughput. I'll bet almost everybody in this room, when you got your home internet service, maybe you upgraded from 300 megabit to 500 megabit, what's the first thing you do? You go to speedtest.net and see if you're getting what you pay for. We run iPerf. There are lots of tools for measuring throughput. Latency, if we measure it at all, is measured really badly. We use ping. And a lot of these tools, like speed test, would tell you, make sure your network's idle, because you can't measure the ping time when you're using the network. It has to be completely idle. Well, that's like measuring the performance of a car when it's sitting on cinder blocks in your driveway with the wheels off, right? That's not how you drive a car. And because of this, we've made enormous progress on throughput, but not on latency. Buffer bloat still affects lots of people. And we accept when we're using video conferencing that it just doesn't work sometimes. There are glitches, the audio drops out, the video freezes. Marvelous as Meet Echo is for our meeting this week, we will have these glitches and they're so common we don't notice them. But the fact is we know how to fix it. And the key to that is not just developing technologies like L4S, it's developing the benchmarks that let engineers know if they've actually implemented L4S correctly or something else. It doesn't have to be L4S. What matters is the benefits we give to the end user, the better user experience. And there are 2 things about the RPM tool. The first one is that we measure network latency under realistic working conditions. In other words, when you're using the network, not when it's idle. And the other thing is sort of a superficial thing, but I'll mention it here. When we report latency in milliseconds, that's a bit of an abstract concept to most consumers, not the people in this room, but a millisecond is such a small amount of time, who cares? So for this tool, we decided instead of reporting latency in milliseconds, well, you take the reciprocal of milliseconds, and that gives you hertz, which is also a bit of an abstract concept. Multiply that by 60, and now you've got round trips per minute, which has this cute acronym RPM, and people are used to RPM of their car engines. And coincidentally, the range is about the same. It gives you a result that can be rounded to an integer. It's normally 3 or 4 digits. 100 RPM is really sucky. 10,000 RPM is awesome. So it's a metric where bigger is better. What am I calling out for here? We really want input from people who work on video conferencing and similar applications, because this test is only useful if it's measuring the right thing. We want this test to be a good predictor of user experience. And we think we know how video conferencing apps work, but we want the people who actually write that software to give us their input, because if this test is a good measure of what they care about, it will motivate vendors to optimize that behavior, which will make your video conference application work better. This is your chance to shape the internet to work to the benefit of your app. So come to IPPM tomorrow and please give us your feedback on that draft.
So next up, we have the formal analysis of a tested TLS for confidential computing with Muhammad. Here you go.
Thank you very much. Okay, welcome everybody. And this is work that we have already presented at the IETF a couple of times. And I want to, oops. Okay, so there's a bit of lag. Okay, so the idea is basically that we use TLS in our daily lives. It's the one of the most commonly used network protocol. But there is a problem that it relies on the secrecy of the key, which is namely from the server side or from the client side. How can we be sure that it's actually protected? So that's where attested TLS comes in. for the endpoint security in order to complement the network security, which TLS is good at. And the use case for this is that we have confidential computing, which Manu just talked about, and it doesn't work without attestation. Attestation is the key enabler of that technology. So the idea is very simple, that we have two things now. One is network security, one is endpoint security. How do we combine the two things together? So we can have one thing first and then do the second thing first sequentially, and then the other way around, the second first and then the first one. Or we could merge them all together so that they basically happen together at the same time. And that's what the three options are shown here on this slide, which is that we have pre-handshake attestation, which is the attestation happens first, gives a output to the TLS handshake. The other one, which is the TLS handshake, happens first and exports some key material to the remote attestation. And the third one, that they're both basically happening in parallel and giving feedback to each other, which is a strong binding, the strongest kind of binding that we can have. So what we are proposing is basically to analyze all of the three options. And we have this figure is basically showing client as an attester in this case. And in green is the evidence at which point of time we can transport the evidences. So this is basically representing all the three forms. In pre and intra, we have, you see that in 2.5, and in post handshake attestation, you see at 3.1 and 3.2. So these are the three different options. And the issue here is that each vendor is proposing its own or using its own proprietary protocols. And in security, it's not good to have such kind of protocols which are buggy and so on, and all the problems come in. So what we want to do is to standardize a protocol which is proven to be secure, and then everyone can actually use that protocol. So that's our proposal. So this is one of the works that we did to analyze the one of the solutions, which is for the pre-handshake attestation. And that uses, basically the protocol is Intel's RATLS, 90% or roughly like that of the solutions in confidential computing are actually using that. And we found it that it's vulnerable to the protocol does not provide the freshness of the evidence. You don't know whether the evidence is recent or is it stale. So you cannot distinguish between the two. And the other property is the server authentication. If by some means, and there are various means by which a key can leak, the priv EK shown in the table, and like side channel attacks, or if there is a vulnerability within the TE, like TDX down, which is a very recent attack, so it can still happen. And in that case, it does not protect at all. There is no use of combining the two things. Okay, so what we are looking for is basically a set of collaborators who can help us in this work, and that can have some expertise in one of those, at least one of those areas, which is TLS, remote attestation, formal methods, and specifically symbolic security analysis and confidential computing. So whichever area you lie in, please talk to us. And we have a couple of side meetings which will describe these in more details, the basic and the advanced versions. And this slide has all the pointers to the resources if you want to have a look at. We will cover from the very basics, and all of you are very welcome to join the side meetings. Thank you very much.
All right, Shigeya, please come up for introduction to originator profile. Thank you.
Hi, Shigeya Suzuki from Keio University and also from WIDE project. Today, I'm wearing a different hat, which is originator profile, collaborative innovation partnership. It's hard to remember, and I still can't remember. Okay, and I'm talking about the invitation to the side meeting on the originator profile technology. So what is OP? OP enables end users to identify the originator or publisher of the information or content on the internet. Especially we are designing this for the news outlets such as the newspapers or other type of web media. So it is rather than certifying whether the content is correct or not. And the what OP provides for the media outlet on the web is that we are trying to provide a content authenticity of content attestation on a fragment of the web information, not the entire web page, but a part of the web page, right? Like a part of the document which specific to the specific news article, for example. The interesting part of this technology is that the origin identity, which is we are saying that mentioning about this name and the originator profile, include a proof of their existence and also different certain kind of the certification from the different certifiers. So this is an example of the page. So it is currently developed as of course on the data embedded into the web pages, and also as the extension which decodes and check or proof of the entire data. And once you press the extension button, then you can check the source of these contents. So the interesting part of the thing is that it is consists of the generic part of the component identity data model and the presentation. And also we designed the entire ecosystem, including SCM, to provide as a software stack to the web publishers. So let me skip this. So I'm going to run a side meeting to introduce this technology, and it will be probably overlapped on the lunchtime. So please come after quickly have a lunch to join the meeting, and I'm going to provide a little more detailed information about this technology. Thank you very much.
All right, where are we? David Van Hook, please, preventing denial of service attacks on TLS handshakes.
Thank you.
Thanks.
Hello, I'm David Van Hoek. I'd like to talk a bit about TLS handshakes and the problems they pose for denial of service attacks. So the problem I've been handed through my work is that one of the fundamental things about TLS handshakes is they're fundamentally asymmetric in their computational effort, in that it's very, very easy to create a client hello that sends a server on a merry path of calculating a full elliptic curve Diffie-Hellman key pair by just generating a bunch of random bytes in a few places and sending it on the wire. This is actually an attack that now seems to be starting to actually be used against people. In particularly, we have heard tales of people from the financial industry where it's being used against them to disable 3D Secure. And for those of you who don't know 3D Secure, this is basically the extended validation on credit cards if you pay with them online, which causes the banks to fall back to the simple method of, oh, it'll be fine, which allows them to use stolen credit cards. Lovely. So the attackers here have quite a bit of incentive to try to do these sorts of attacks. And really, there's no realistic way to defend against this. It's fairly cheap for them to generate a lot of client hellos, and you need multiple cores on a server to deal with even a gigabit per second of these things. So one of the things we're looking into right now is something called client puzzles, which is basically saying to the client, hey, you want me to do work? Are you sure about that? Just solve this puzzle for me first, and go off, do some work first. Show that you're really serious about this. This allows you to basically throttle all your clients. For normal clients, this is hopefully not too much of a problem because they'll likely need to solve maybe one, maybe two if they're sending a lot of requests your way of these puzzles. This is actually an idea that's been around before. It's been suggested a couple of years ago when TLS 1.3 was still being developed. Never really got traction. People just didn't see this as a realistic attack vector. Well, guess what? Became a realistic attack vector. So we're trying to revive this. And specifically, we're looking for people to talk to on this. Also on any alternative solutions to maybe how we can make this better. So I've already heard things about faster signatures might help us here, maybe even batching those signatures. Optimizing auto stuff in the whole pipeline. If you have any other suggestions on this, please come talk to me. Same holds if you're a browser vendor or in that sort of corner. Please tell me why these puzzle things are a horrible solution and what we should use instead. I'd love to hear it. That was it.
All right. Thank you. Well done. All right, Stuart, come on back up. TCP replenish time.
Thank you. So this starts with a little story that goes back 13 years. I was using remote screen sharing to my Mac at home, and it was really sluggish. And it was over a slow DSL line, so maybe that's not surprising. The network's slow, you expect it to be sluggish. And this was 2011. I just learned about buffer bloat from Jim Geddes. So my first reaction was to blame the network. Oh, it's buffer bloat in the network. I did some investigation. And in this case, it wasn't. But there was a 2-second lag between clicking on a menu and seeing it appear. And when I started digging, it's like those horror movies. The phone call was coming from inside the house. The buffer bloat was on the computer itself. It wasn't in the network. So this is what was going on. With BSD sockets, as it was back then, the screen sharing application would grab a frame, compress it, send it to TCP. It would go into the socket send buffer, and TCP would say, please, sir, can I have some more? And the screen sharing would grab another frame, compress it, send it, grab another frame, compress it, send it. Those frames weren't going out in the wire. They were just sitting in kernel memory in the socket send buffer, waiting for TCP's congestion control algorithm to decide it was time and the network could handle that data. So we had some data in flight, which is good to keep the bandwidth delay product full, to make full use of the pipeline, and a full 2 seconds of stale frames just sitting in RAM. Well, this isn't helping the user experience. So to combat this, we came up with a socket option, the TCP not sent low watermark. And the way this works is when an application like screen sharing is blocked waiting on K event for a socket to become writable, TCP doesn't tell it that the socket's writable until it's actually getting close to needing that data. And that simple fix, I worked with the kernel team to put it in the kernel. I then sat down one afternoon with the screen sharing engineer, added this new socket option to screen sharing, and it dramatically fixed the lag with screen sharing. And this is the after picture. You still have the blue data in flight to keep the bandwidth delay product full, but you have a tiny bit of data waiting to go out. And you don't actually invite the application to give you more data until you're ready for it. So that's great. There are 2 problems we've found. One is that we specified the trigger point for the socket being writable as a low watermark in bytes. And about 16 kilobytes, about 10 Ethernet frames, works well for a wide range of cases. But at very low data rates, 16 kilobytes is a lot of data. It can be a second of latency. And at multi-gigabit rates, it's not enough time for the application to replenish the data. So we realized it'd be better to specify the delay in time. The application is saying, give me 20 milliseconds notice and I'll give you more data. The other problem is this was also implemented on Linux, and I was overjoyed. I want this to be cross-platform. I want all software to be better. But it was done differently. On Mac OS, it is a low watermark. When the unsent data drains to that level, you then trigger the application to send more. On Linux, it was implemented as a high watermark. It is the upper limit of what the application can send. So for people writing applications, it's the socket option with the same name, but it has opposite behavior. So I think it's time for us to fix this. I have scheduled a side meeting for Thursday. If you're interested, please email me, cheshire@apple.com, to let me know, because if nobody's coming, I'll be down the pub instead. But if we're having a meeting, I'd love to talk about this with implementers.
All right. Eve Schooler, come on up. Proposed sustain RG, sustainability and the internet. Thanks. Eve.
Okay, start the clock. All right, I'm Eve Schuler. I've been working with several people to put together a proposal for a new research group for the IETF. And this is going to be a bit of a whirlwind teaser to invite you to come to a side meeting later this week. Where am I supposed to- Okay, why a research group? Why now? Because it's pretty urgent. If you've been paying any attention to the press and to the world at large, you know that we are trying to avert the worst kinds of side effects of climate change. And in order to do that, we are trying to adhere to some recommendations by the trusted UN Intergovernmental Panel on Climate Change to try to reduce emissions, greenhouse gas emissions, carbon and so forth, reduce them to 50% by 2030, 100% by 2050. And of course, our industry, the information communication technology industry, contributes a sizable and growing percentage of the environmental impact in terms of our electricity usage, in terms of our carbon emissions and so forth. And networking, despite the fact that data centers get a lot of attention, the networks themselves have an impact that rivals that of data centers, at least according to the last reports out of the ITU. Clearly, again, if you've been looking at our newspapers recently, all of this has been exacerbated by AI and the growth in data centers and data transmissions. Well, how do we as a community typically define sustainability? Largely, we focus on the consumption of less energy as being our definition of being sustainable and green. But we know full well that we can't energy efficiency our way to net zero. And as a result, we really need to also concentrate on decarbonization of the energy that we use. We need to additionally look at the minimization of other kinds of environmental resources that we're using in terms of water, land usage, waste, pollution, and so forth. In the broader community, when they talk about sustainability, they say, our goal is to meet the needs of the present without compromising the ability of future generations to meet their own needs. And the UN, again, their sustainable development goals have identified 17 sustainability items that we should really be paying attention to. And those can be roughly placed into 3 buckets or 3 pillars. And we've talked about the environmental ones, but they're equally important ones that have to do with social and economic sustainability as well. And so the vision for this research group is to contribute to the advancement of the internet as a fundamental part of a sustainable and resilient society and planet through the conceptual and evidence-based research collaboration. What do we really mean? In the internet, in the IETF, our expertise is in networking design perspective, and we want to be focusing on long-term research, the trustworthy dissemination of information, which in this community is often questioned. We want to talk about the linkages between architecture and policy, and not only talk about the negative impacts of the internet, but also the positive ones. There are many issues that go beyond the technical in order for us to be successful that have to do with the fact that come to our session and hear about all of these issues. The internet uses way more electricity, for example, than other developed countries and so forth. We need to have both carrots and sticks to incentivize companies and our community to do well, and ethics and so forth. We're going to go into a lot of issues with regards to our expertise as well as linkages to these other communities. And finally, we have a lot of other people that we want to work with. Can I just go back and tell you there's going to be a side meeting? Come to our side meeting. It is going to happen on Wednesday. Thank you.
Okay. All right. And if you think the sustainability stuff is interesting, you're also going to be interested in the next lightning talk. Hamid's going to talk about real-time telemetry for carbon-aware networking. Go for it.
You're going to start the timer.
She's going to start the timer. And she started the timer.
Hello, everyone. My name is Omid, and in this presentation, I talk about the need and the importance for design and implementing real-time telemetry solution for carbon-aware networks. Currently, ICT consume 2 to 3% of the world electricity, and we predict this number grows up to 21% by 2030. Recently, we have seen many efforts that have been done to make data center energy efficient, although networking lagged behind due to several reasons, including complexity in measurement. So we should note that quantifying and reducing consumption of electricity is not an easy task. We have many contributors, such as client, infrastructure, communication link. There is a lack of standards and tools for collecting data. And also most of the metrics that currently we collect by using network monitoring tools related to security and performance, not carbon or energy consumption. So knowing the total electricity does not reflect the environmental impact of computer networks, and we need to consider carbon intensity, which is the amount of carbon emitted per unit of energy. In order to define an effective carbon efficient telemetry method, we need to have an end-to-end approach. And in this method, devices need to collect this data real-time or near real-time. And also we need to have access to real-time carbon intensity data. And also we need to have application and services that react to this data in real time. One of the challenges that we have in this way is network equipment manufacturer currently report the maximum power consumption, which is different with the actual carbon emission of the platforms. Absence of hardware support does not mean that we need to wait for devices to come to the market, and we can leverage proxy data that indicate carbon consumption. Again, we need to notice that electricity consumption is not equal with carbon consumption. And when we talk about carbon intensity, we need to notice about the source of the energy. Also, although we have carbon intensity data, but this data is not complete. For example, in some region, we don't have this data, or the frequency of updating this data in different regions are different. So in order to implement an efficient method for network telemetry related to carbon efficiency, we need to have this solution supported by both energy provider and network operator. Energy provider needs to give us data about carbon intensity, and network operator need to process and propagate this information as a part of the telemetry solution. In conclusion, such as any other part of the digital infrastructure, networking needs to be carbon efficient, and we need to have a standard metrics that supported and reported by network devices. Based on this, we call out IETF community to join the effort for defining this metric to make networking truly green. Thanks.
Hi, Wenting Chang, PSI based on ECDH. You got this.
It's my pleasure to give you this presentation about PSI based on ECDH. So before I introduce the technology, I want to first share the use case of this PSI. So for example, if you have two companies, company A has a list of people who have bought their product, while another company that may have the candidate list that who have viewed the advertisement. So here we need to calculate their intersection without revealing additional data. So for example, so in this use case, the intersection is that the people who have seen the advertisement have buy the product. And then with the data set without the intersection is unknown. So this is a user case one, that how can we calculate the intersection without revealing additional data. So this is another use case. So here, for example, that if you have a bank who want user to use their card to buy things. And then there is another online platform. They can offer you. They have the channel to offer users the discount to encourage them to pay the money with the bank card. So here in this case, we need to find out the intersection that who is the user of both payment platform and the bank. So in this way, the online platform can help the bank to boost their user to use the bank card. So this is two user case. So based on this two user case, we are trying to introduce a technology or protocol that's PSI, private site intersection. So in this technology, we realize that two parties can calculate the intersection for the data who outside the intersection is unknown to the other party. So this is what we are going to propose. So in order to realize it, we need two things. One is that a protocol which will negotiate the required parameter and the data to exchange. And then the other thing is that the data message structure, so that different parties can realize the grammar and the semantic consistency. And then we have prepared some PSI algorithms. So this is the list. I won't go to the details. So here we focused on the ECDH PSI. The why is that it has been it's very easy and has limited requirement and etc. and the security. So this is the technology. Here I will go through the I will go quickly. And so this is the algorithm that we want to propose, that two people can exchange the message to realize the intersect calculation. And then we have this time we have proposed a draft in this IETF. You can search ECDH. Thank you. And one more, that we have the code is open source. If people is interested, please contact us. This is our contact information. Thank you very much.
Thank you. Thank you. All right. I think that's it. My goodness, you guys did it. Congratulations to everybody who finished on time. Congratulations to everybody who almost finished on time. And congratulations to the audience for our properly applying.
The wrong number. But see you at 122. We're at 121.
Oh, yes. That's my cat, by the way, and he's judging. He's a very judgmental cat. So you go, Chaucer. Thanks for coming, everybody.
I like your intro.
Thank you.
Yeah.
It was